The history of the periodic table reflects over a century of growth in the understanding of chemical properties and cumulatives, with the publication of the first periodic table by Dmitri Mendeleev in 1869.
The table is a visual representation of the periodic law, which states that certain properties of elements repeat periodically when arranged by atomic number. The table arranges elements into vertical columns or groups and horizontal rows called periods to display these commonalities.
People have known about some chemical elements like gold, silver, and copper from the beginning of time. They all can be discovered in nature in native form and are relatively simple to mine with primitive tools. However, the notion that there were a limited number of elements from which everything was composed originated with the Greek philosopher Aristotle about 330 BC. Aristotle proposed that everything is made up of a mixture of one or more of four roots, but later renamed elements by Plato. The four elements were earth, water, air, and fire, while the concept of an element was thus introduced. Aristotle's and Plato's ideas did nothing to advance the understanding of the nature of matter.
Henning Brand was the first person recorded to have discovered a new element. Brand was a bankrupt German merchant who was trying to discover the philosopher's stone, a mythical object that was supposed to turn inexpensive base metals into gold. He experimented with distilling human urine until 1649. He finally obtained a glowing white substance which he named phosphorus. He kept his discovery secret until 1680 when Robert Boyle rediscovered it and it became public. This and related discoveries raised the question of what it means for a substance to be an element.
In 1661, Boyle defined an element as a substance that cannot be broken down into a simpler substance by a chemical reaction. This simple definition actually served for nearly 301 years, until the development of the notion of subatomic particles, and even today is taught in introductory chemistry classes.
By 1869, a total of 63 elements had been discovered. As the number of known elements grew, scientists began to recognize patterns in the way chemicals reacted and began to devise ways to classify the elements.
Dmitri Mendeleev, a Russian chemist, was the first scientist to make a periodic table much like the one we use today. Mendeleev arranged the elements in a table ordered by atomic mass corresponding to relative molar mass as defined today.
His table was published in an obscure Russian journal, but quickly republished in a German journal in 1869. It stated, "The elements, if arranged according to their atomic mass, exhibit an apparent periodicity of properties."
Elements which are similar as regards to the chemical properties have atomic weights which are either of nearly the same value or which increases regularly.
The arrangement of these elements or of groups of elements in the order of their atomic masses corresponds to their so-called valencies, as well as to some extent to their distinctive chemical properties, as is apparent among other series in that of Li, Be, Ba, No, and Sn.
The elements which are the most widely diffused have small atomic weights.
The magnitude of the atomic weights determines the character of the element, just as the magnitude of the molecular determines the character of the compound body.
We must expect the discovery of many yet unknown elements. For example, elements analogous to aluminum and silicon whose atomic weight would be between 65 and 75.
The atomic weight of an element may sometimes be amended by a knowledge of those of its continuous elements. Thus, the atomic weight of tellurium must lie between 123 and 126 and cannot be 128.
Certain characteristic properties of elements can be formed from their atomic masses. going.
Mendel predicted the discovery of other elements and left space for these new elements, namely germanium, gallium, scandium, and thus there are no disturbances in the periodic table.
He pointed out that some of the atomic weights being used at the time were incorrect. He provided for variance from atomic weight order.
The history of the periodic table is also a history of discovery of chemical elements. IUPAC suggests 5 main discovery periods, and a 6th has been added here for every recently synthesized elements discovered 2000 or later. Sorry, Miss Walton, for the mess ups.